Okay, so here we are just down at the mouth. I'm kind of in a little bit because the wind's up, but you can see the Red Cedar River flowing down there. So here's the mouth of Galloway Creek flowing into the Red Cedar. Although the wind is strong enough, you can see that actually some of the water is actually flowing and getting pushed upstream as a result of the wind. Also, as the Lake Monoman Dam lets out, sometimes the water level in the Red Cedar River rises, and so we actually get sort of backflow up into the mouth of Galloway Creek. So one of the questions is, well, how much of this landscape is influenced by Galloway Creek, and how much of this landscape is influenced by the Red Cedar? And where we are, we're probably looking at more stuff that the Red Cedar is doing. And one of the important things the Red Cedar is doing is it's basically creating the lowest level to which Galloway Creek can flow. So Galloway Creek flowing way up over there, up past the community farm, down past through town, past campus, and then down past the high school, and then down out and over to here. So at this point, we're looking at basically the lowest elevation that Galloway Creek can go. So this is the lowest point to which it can degrade or erode into the landscape, because if it goes any lower, the Red Cedar River is just going to backfill and prevent the river from going any lower. So this is what we call the base level of the stream. In this case, the Red Cedar River is acting as the base level for Galloway Creek. So if we go up Galloway Creek a little bit, so I've got my camera on a little monopod, so we'll kind of walk up the stream a little bit here, and we'll take a look. First of all, one of the things to notice is look at a lot of actually large blocks of sandstone bedrock, and then you can see here it's sort of falling into the stream and creating this little sort of area of very turbulent, very sort of fast moving and bubbling water. So this is an area that this is what we would call a riffle along the stream itself. And if we look up a little further, you can see the water's more calm, and we would call that a pool. And so this pool and riffle sequence is a really important set of ecological habitats that maybe I'll be able to talk about more later. But going back down the stream, so we have some soil covering and acting as some of the material that the river is eroding, but we also have large chunks of bedrock material. And the bedrock material is obviously going to erode differently than the soil itself. And we're going to see that effect in the creek as we kind of go up. So here we go towards a little pool. And there's our little pool. And you can see up ahead, we have some more riffles and actually a nice waterfall. And there's another nice waterfall up there. And you can trace that line of bedrock all the way through. And so the stream is actually now tumbling over this ledge of more resistant bedrock, creating a little waterfall. And then, of course, it's flowing into this pool. And then the still water is then flowing into more turbulent riffles downstream. So one of the things that's happening then is that as Galloway Creek is trying to erode downward, it's hitting this resistant bedrock, and it's not able to go downward as evenly and completely through that bedrock, and so it's basically kind of falling over some of these little ledges. And of course these ledges are eroding, so these waterfalls are eroding and moving their way upstream as the river is carrying sediment away towards the Red Cedar behind us. Alright, and it doesn't look like I can make the trail from this side, so I'm going to have to go up and over. Alright, so we're now above the waterfall that we were looking at before. And we're a little bit closer to the other taller waterfall there, and you can see here's that bedrock. Some of it is pretty soft, falls apart easily. Some of it is much more resistant. And one interesting thing is if you look right here, These are ripple marks, but ripple marks preserved in the sandstone bedrock. So these are about 550 million year old ripples from when the sand was being deposited on an ancient marine beach. And so it's kind of cool to think that we have really old sedimentary features preserved and basically being eroded and reworked by modern river activity. So let's see here, we've got our river, it's trying to erode, and of course it's hitting these resistant layers and it's forming these little waterfalls or drop points. In a more general sense, we would call this a nick point, where the river tries to erode lower and it erodes backward, but it hits a resistance spot, so you have a little step in the elevation of the stream as it goes over this little resistant ridge, and that step then is going to erode backwards. It happens in soil as well, but it generally isn't as pronounced, and it also tends to erode back much faster. So here is another little pool with some riffles, so you can see that we're really mixing up the water there, and then we're letting the water kind of sit and be still. It's also a lot more open, so it's going to get a lot more sunlight, probably a lot more thermal energy as well. And then back on down towards the Red Cedar. Alright, so we're back at the mouth of Galloway Creek. You can see Galloway Creek flowing through here, and then it enters the Red Cedar. And if we look out, especially the water's up pretty high, but at low water you can actually see this little shape of land here. This is a large, quite a significant little spit of gravel and bedrock flagstones that have been pushed out by Galloway Creek and have then been since pushed downstream further by the Red Cedar River. But here you can see some of the sediment being introduced to the Red Cedar from Galloway Creek is actually sort of starting to interfere or modify the flow of the Red Cedar just a little bit. And how much modification takes place really depends on the size and scale of the stream. And so there you can see there's that, right? So this is more or less the actual active floodplain, the stuff that gets inundated probably, you know, every 1.5 to 2.5 years. And then here we have one of the terrace surfaces there. And if we look across the river, you can see there's Lakeside Park. Lakeside Park is also a nice terrace remnant. And then we look over across the Incarnation plant and the storage buildings, that kind of low-lying area, and then right campus sits another about 30-40 feet above that over on that direction. So the Red Cedar has also dropped and eroded down into its riverbank, and by eroding down in its riverbank, the Red Cedar has essentially lowered the base level, allowing Galloway Creek to further erode downward. So I'm going to go grab a whiteboard and find somewhere that's a little bit out of the wind to diagram this out for you, to kind of help you with the lab activity as well. Alright, so I'm back down here kind of in a little ways to try and get out of the wind. I also brought a little whiteboard to try and kind of give you a diagram of how to think about this whole process, just in terms of aggradation and degradation. So if we think about Galloway Creek, so Galloway Creek is going to start off at some high elevation along the drainage divide for the Galloway Creek watershed, and it's going to start sloping down. And if we look at the terrace surface, so the high terrace surface that kind of marks, you know, where campus is, as well as kind of over by the high school, we can see that the elevation, or the change in elevation of Galloway Creek with distance so distance from the mouth, so here's the mouth and the Red Cedar, we can see that those terraces and the landscape of the hills along the drainage divide make a fairly nice kind of smooth profile. We call this a graded profile because it basically kind of has a nice gradation from high elevation to low. Most of the elevation change is up near the headwaters, and near the mouth the elevation change is much more gradual. And this profile, where we track the surface of the terraces, is pretty close to what we would consider a stream in equilibrium, where there's a balance between the degradation or erosion of sediment and the deposition or aggradation of sediment. Well, if this is our Red Cedar River, and it was at this elevation too, back kind of just after the Ice Age, well, we have a nice, relatively graded profile between Galloway Creek and the Red Cedar. But the Red Cedar, once the glaciers melted away, all of that sand and clay and silt and boulders that was being pushed down by the glaciers, basically that source of sediment went away. And when you remove the supply of sediment to a river, that river's got to do something with the extra energy, and so it's going to start eroding downward. And so the Red Cedar, since the last Ice Age, has eroded downwards probably about 50 to 60 feet in the Menominee area. And so, right, because the Red Cedar River is just above 790 feet. Campus, actually the upper part of campus, is about 860 feet above sea level, so it's been a good 50 to 60 feet of erosion since the last Ice Age. So the Red Cedar River has dropped down this far. So the base level of Galloway Creek, which used to be, so I don't want to use green, that's going to be, right, base level controlled by the Red Cedar used to be right here. Well, now the base level is down here. But of course the river itself is still perched on top of this terrace, so it's basically got to go down here. And so it's forming that little steep part. It's not that drastic. It was eroding downward as the Red Cedar was going downward, but it had a little drop there. We call that a nick point. And this nick zone, or nick point, was starting to erode backward as Galloway Creek was starting to flush this sediment out. And so what we end up seeing is that the current profile for Galloway Creek goes down to the Red Cedar, controlling its base level, and it goes up, and then there's one of those waterfalls, goes up, another one of those waterfalls, it goes up towards campus, and then right around the Loyal Order of Moose baseball field, that's kind of in front of Phelan Park there, we can see that the Galloway Creek profile then kind of comes back up and matches this more graded profile. So Galloway Creek has eroded downward and flushed all of this sediment that used to be filling the Galloway Creek River Valley down into the Red Cedar, which then has transported that sediment down towards the Chippewa, which then has transported that sediment into the Mississippi, which has brought that material into the Gulf. What we have now is the profile of Galloway Creek is no longer this nice equilibrium profile where the concave surface is pointing up, so we call this concave up in terms of a graded profile. Well, in this case, that surface actually has sort of a convex upward surface. And so this convex upward surface, where we have this sort of slope, this kind of hump in the middle, or these little lumps where these nick zones are eroding backward, that is a profile of a stream that is out of equilibrium. And of course the stream, doing what it does, it's trying to reach that equilibrium point. So at some stage these nick zones are going to work their way back. If the Red Cedar doesn't change in elevation for the next, I don't know, 5,000, 10,000 years, we're probably going to see a slope of Galloway Creek that looks something like this. But it's got all of this material to work through, and a lot of this is resistant bedrock. It also, of course, has, you know, the city of Menominee to contend with, where they've lined much of the channel of Galloway Creek with cement. Probably more about that next week. But in terms of a stream profile, we're really just looking at how close to an equilibrium concave up shape does it have. And deviations from that tend to indicate something has changed in the river's history. Alright, it's really frickin' cold. A couple other things that I'd like to say, but I'm going to find somewhere else that's out of the wind. Plus, I have no idea how the wind is affecting the audio, so hopefully you can hear me.